Well, a warm welcome to everyone joining. Thanks for coming back. If you want to get yourselves ready, you should have a notebook, grab a pencil or pen, whatever you choose to write with. It's fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we are continuing with our Star Wars Calc AB Practice Standards series. I call this the Standards series because these questions are not 100% the difficulty that you should expect on the AP exam. However, the types of questions that they're asking in each part does give you the fundamental process of what you should be doing to answer questions in calculus and on the exam. So that being said, we see that there are 4 parts here. I think it'd be a good idea for you to give yourself about 12 minutes. That's sort of the goal. Sub 12-minute time is a great time. Technically, you'll have 15 minutes per question on the AP exam. And we're going through the non-calculator questions first because this will give us the opportunity to practice some techniques without using any technology, which is where most of the points come from anyways. And the calculations will also be kind of light, so don't think that you're going to be breaking your back trying to do some of these calculations. All right. So once you've paused the video and given yourself a moment to try to answer this, you can look back at the video and see how we did the part-by-part solution here. All right, let's get started. Now, we have this equation which has x and y in it. Y is in multiple places. We're not going to be able to isolate the y. We have a y squared and a y, so we're not going to be able to simplify just a y expression on one side, which means, implicit differentiation. Part A says to write an expression for the slope of the curve. Now, the slope of the curve still is dy dx. That is still the slope of the tangent line. So the tangent slope. The thing is, with these curves that are, they're curves, not functions. These curves that have y in multiple places like this, these still have tangent lines. However, the slope of a tangent line could possibly depend on x and y, not just the x value. So if we want to find dy dx, we need to do implicit differentiation here. So let's be careful with that. On the left side's very involved. So we have 2x, that's pretty straightforward. Then for this y term, anytime we do a derivative of y stuff, just treat it like it's an x, but of course, call it y. And then make sure you sort of slap a dy dx on it because we have to multiply by the derivative of y as per the chain rule. Now here we get a little product. So be careful, make sure you know what to do with a product. How do we do the product rule? That's pretty easy. We take the derivative of the first thing, leave the second thing alone, plus we leave the first thing alone and take a derivative of the second thing. So this is going to be 3 times y, leave it alone, plus 3x, leave that one alone, times derivative of y dy dx. And on the right side of the equation, the derivative of -4 is just 0. Nothing really to worry about there. Let's move everything without dy dx on the other side. So we're going to have a -2x and we're going to have a -3y. So now everything only has dy dx on it. What has dy dx on it? That's going to be -4y plus 3x. So if we simply divide this thing off, then we get an expression for the slope, which is dy dx is -2x minus 3y over -4y plus 3x. I want to take the moment to mention that if you got this question on multiple choice and were asked to find dy dx, it's possible that they wouldn't have the answer looking exactly like this. The AP exam likes to trick you with the way they present the answer on the multiple choice. So you could possibly have the negative factored out of this 2x plus 3y, and then have the negative factored out, and this would be 4y minus 3x. And so it's possible one of the answer choices on a multiple choice exam for the dy dx, the slope of the tangent line to this curve, it's possible they would write the answer choice like this, and this would be the correct answer. These are equivalent. There are other ways you can kind of work this around a little bit, messing with the negatives and such, but I just want to warn you that when you take the AP exam, they do this kind of thing on the multiple choice section. Okay, so for our purposes, I think we'll just use this one here. Pretty straightforward, unless you want to use this one. I kind of like it now that we have it. Yeah, let's go ahead and use that one as dy dx. Now that we've gone out of our way to mention what it would look like. Okay, let's get moving. We're wasting time. Find the equation of the normal line. Whenever I see equation of tangent or equation of normal line, I want you to write the following: y minus y value, or you could put y minus y1 equals m x minus x1. That is the equation of a line in point-slope format. We already have the x1 and the y1. That's very nice. 1 comma negative 1. What we don't have is the slope. And you have to be careful because we don't want the slope of the tangent line. We want the slope of the normal line. Right? That means we're going to take the negative reciprocal of the tangent slope. So first let's find the tangent slope. Let's say dy dx at the point 1, negative 1. That's going to be 2 minus 3 over 4 plus, over negative 4 minus 3, because the x and the y's are switched there. So this is going to be negative 1 over negative 7, or 1/7. That is the tangent slope. That means that the normal slope is going to be negative 7. Okay, so we have to use this slope for our tangent line. For our normal line. So this is going to look like the following. Y minus negative 1, or y plus 1, equals negative 7 x minus 1. And that is our normal line equation. Yeah. Okay, part C steps it up in terms of derivative a little bit. It asks, what is d squared y dx squared? What does this even mean? This is the second derivative. Okay, so that's the expression for the second derivative. And it's at the same point. So let's find an expression for the second derivative. We saw that the numerator was 2x plus 3y over 4y minus 3x. That's the dy dx. So if we wanted the second derivative, we need to take a derivative of the derivative, right? So this is going to require the quotient rule. So however you've memorized the quotient rule is fine. Some people know. One thing that I know about is the whole low-de high, high-de low, ho-de high, high-de ho, whatever you want to call it. So we have the low function, the bottom function, times the derivative of the top, which is 2 plus 3 dy dx, minus high d low, which is the top function, that's the high, times d low, that means the derivative of what's below, that's 4 dy dx, minus 3. And this is all over 4y minus 3x squared. Now, you see dy dx in there. You don't have to replace dy dx with this. You don't have to plug that in. We can just leave it. We'll plug it into the dy dx and just use whatever that number is. Now, didn't we already plug that in, though? We did. We plugged in 1, negative 1, and what did we get? We got negative 1 on top, negative 7 on bottom, so we got 1/7. So we already know what that value is. It's 1/7. So at the point 1, negative 1, we have that this becomes negative 4 minus 3, so that's a negative 7. 2 plus 3 times 1/7 minus 2 minus 3 times the quantity 4 times 1/7 minus 3 all over Well, that's going to be negative 4 minus 3 again, and then squared. So let's work this out just a little bit. On the bottom, we're going to have 49. And on the top here, we're going to have negative 7 times 2 is the same as 14 sevenths. So we have 17 sevenths, and see how that's going to work out really nicely? Minus, what do we have here? Negative 1 times, well, 3 is 21 sevenths. So 4 minus 21 sevenths is going to be negative 17 sevenths. Lots of negatives there, guys, so be careful. Don't get too tripped up there. These sevens cancel nicely, and that leaves us with negative 17. And then this becomes positive, but then this becomes negative again, minus 17 over 7 over 49. Lots and lots of sevens. Let's see, what's the best way to deal with this? I guess we should just get this a common denominator. So 17 is 17 times 7 sevenths, which is 119. So we have negative 119 minus 17 all over 7, and then that's all over 49. This is simply going to become negative 136. I know I say simply, right? Simply going to become negative 136 over 343. Now, 343 is only made up of sevens, so if 136 does not divide by 7, which it doesn't, we can't simplify this at all. So that is the second derivative at that point. That's definitely some calculation involved. I know I said we're not going to break your back with calculations. I don't think this really breaks your back. What did you have to do? You had to multiply by 7 a couple times, right? Plug some stuff in. Not so bad. Okay, let's look at part D, which asks if 3a comma negative 2a is a point on the curve, meaning if this is x and this is y, determine the nature of the line tangent. So what it's asking is like, what's going on with the slope there? It's asking about slope stuff. When it says determine the nature, like, is it going up? Is it going down? Is it vertical? Is it flat? Those kinds of things. So how can we figure this out? Well, we can plug this point into the derivative, and that's going to tell us what's happening with the slope. How do we plug this into a derivative? Well, we have the expression for the derivative, right? It's 2x plus 3y over 4y minus 3x. So if we just plug in the 3a, that's going to give us 6a. And if we plug in the negative 2a for y, that's going to give us negative 6a. Interesting. On the bottom, we'd have negative 8a minus 9a. So this equals 0 over negative 17a, which, assuming that a is not 0, this just equals 0, which means the tangent line is horizontal at this point. So that's the nature of the tangent line. It's horizontal. We don't have an actual value for what that point is, but if we had some a value such that 3a comma negative 2a is on the curve, then it will be a flat point. Okay, so they really asked us a handful of great implicit differentiation type problems, ones that go along with that topic. They'll have us find either the equation of tangent or normal line. In this case, I like that they did the normal line. It requires you to do that extra step and turn the tangent slope into an opposite reciprocal. And then they made us use the quotient rule here, which got a little bit messy. There were some, I guess, slightly tougher fractions to deal with. Then lastly, we have a very conceptual, abstract question where if we plug in these theoretical values, which have variables themselves, what can we say about the tangent? Well, that requires us to look at the slope carefully and see what's happening with the value of the slope. All right, I think that sums up enough blab out of me. Keep watching this series to continue honing your skills and sharpening your tool belt. That way, when the AP test comes around, you'll be prepared with the standards that you need. See you next time. Avoid.